Picture this: a single pilot racing through hostile airspace at 400 feet, carrying weapons that shouldn't even fit on his aircraft, threading the needle between overlapping radar coverage zones that could vaporize him in seconds. This is the story of precision engineering meeting battlefield improvisation, where American technology and Ukrainian ingenuity combine to overcome one of the world's most sophisticated air defense networks. What happened next would prove that sometimes the most desperate solutions produce the most remarkable results. On a late June afternoon in 2025, as the summer sun blazed overhead, a Ukrainian MiG-29 from the 40th Tactical Aviation Brigade was experiencing what every pilot dreads most: electrical problems at the worst possible moment. The weapon's interface was throwing voltage warnings like confetti, and the pilot knew that somewhere ahead lay a target that could change the course of countless civilian lives. The mission had started routinely enough. Intelligence reports indicated a drone manufacturing facility deep in occupied territory, churning out 40 Shahed attack drones every single week. These weren't just military targets. These drones were specifically designed to terrorize civilian populations, striking power grids, hospitals, and schools with devastating precision. The facility represented weeks of careful planning by Ukrainian military strategists who had identified this single point of failure in the enemy's supply chain. But getting there would require flying through what military analysts call a contested environment, a polite way of saying airspace saturated with enough anti-aircraft systems to turn any aircraft into scrap metal in seconds. The pilot's radar warning receiver suddenly erupted in urgent tones as an S-300 acquisition radar painted his aircraft from nearly 60 miles away. This was the beginning of a deadly game of cat and mouse that would test every system on his aircraft. The MiG-29, originally designed by Soviet engineers decades earlier, was now carrying American-made precision weapons through an improvised mounting system that would make aerospace engineers cringe. 4 GBU-39 small-diameter bombs hung from pylons never intended for such payloads, connected through a maze of battlefield modifications that pushed every electrical circuit beyond its design limits. Ukrainian technicians had essentially performed open-heart surgery on a fighter jet, grafting 21st-century precision onto a Cold War airframe. Each bomb required GPS satellite locks, inertial navigation system calibration, and communication verification with the improvised interface, a process that should take 30 seconds, but had already consumed 2 full minutes. Time was running out, and the pilot could feel the weight of the mission pressing down on him like the summer heat radiating off the cockpit canopy. The target zone was protected by a Krasuka-4 electronic warfare system, a sophisticated piece of Russian technology capable of flooding GPS frequencies with 500 watts of interference. Think of it as a massive electronic bullhorn screaming static into the precise whispers that satellites use to communicate with precision weapons. For most guided munitions, this would mean flying blind into empty fields instead of hitting their intended targets. Fuel calculations showed a knife-edge margin for error. After weapons release, the pilot would have exactly 18 minutes of flight time over hostile territory before reaching what aviators call bingo fuel, the point where you either head home immediately or start looking for a place to crash land. Every second spent in the target area increased the chances of never making it back to friendly airspace. The approach required threading through an 8-kilometer gap between overlapping air defense coverage zones. Ukrainian intelligence had spent weeks analyzing radar positions, calculating blind spots created by terrain features and the Earth's natural curvature. The corridor existed because of simple physics. The S-400 system near Melitopol couldn't see below 800 feet at long range, while the S-300 batteries were positioned to defend against high-altitude threats, creating deadly shadows at extremely low altitudes. Flying this corridor demanded precision that would make a surgeon's hands look clumsy. Drift just 2 kilometers to the left, and the Western S-300 would acquire a perfect firing solution. 3 kilometers to the right meant certain death from a mobile SA-15 patrol route. The pilot had essentially become a human cruise missile, navigating through gaps measured in city blocks while traveling at hundreds of miles per hour. At this point, the mission became a masterpiece of military coordination. Ukrainian Su-24 aircraft had launched anti-radiation missile attacks 45 minutes earlier, forcing enemy radars offline temporarily. Electronic warfare units broadcast false radar returns, creating phantom strike packages approaching from the northwest. These elaborate deceptions drew defensive attention away from the lone MiG approaching from an unexpected vector, creating a 90-second window of opportunity that had taken weeks to orchestrate. The climb to release altitude exposed the aircraft to every air defense system in the sector. Multiple fire control radars achieved lock simultaneously, painting the MiG with enough electromagnetic energy to physically heat its radar dome. The S-400's gravestone radar burned through Ukrainian jamming with 350 watts of power, creating a targeting solution so precise it could guide missiles to within meters of their target. But timing is everything in modern warfare. The pilot had exactly 90 seconds to reach the launch point before entering the engagement envelope, where enemy missiles could reach him in 24 seconds. Every element of the mission had been choreographed to create this brief moment when American precision met Ukrainian determination in the most hostile environment imaginable. The GBU-39 small-diameter bombs represent decades of American military technology development. Each weapon carries sophisticated guidance systems designed to operate in the most challenging electronic warfare environments on Earth. When GPS signals become unusable due to jamming, the bombs seamlessly transition to inertial navigation mode, using accelerometers and gyroscopes to maintain course accuracy that would impress a Swiss watchmaker. As the weapons separated from their pylons, they transformed from ballistic projectiles into guided gliders capable of flying 89 kilometers through contested airspace. Their onboard computers calculated optimal flight paths to converge on the target from different angles, ensuring no point defense system could engage all four simultaneously. This is warfare fought with mathematics and physics, where trajectory calculations matter more than traditional courage. The Russian electronic warfare operators had no indication that their jamming had just defeated itself. The Krasuka 4 system performed exactly as designed, flooding GPS frequencies with interference that should have sent the weapons flying blindly into empty fields. They had no way of knowing that American engineers, who had studied Russian capabilities for decades, had built counters into every circuit specifically to defeat Soviet-era electronic warfare systems. The weapons struck their targets with devastating precision. The first bomb penetrated the assembly building's reinforced roof, its infrared seeker matching thermal signatures with 94% confidence. The second weapon destroyed the electronics workshop, where Iranian-designed autopilots were programmed for specific targets. Without this capability, completed drones became expensive model airplanes incapable of precision strikes against civilian infrastructure. The third bomb impacted the storage warehouse containing 15 to 20 completed Shahed drones, each carrying 40 kilograms of explosives. The resulting secondary explosion destroyed not just the inventory, but the entire logistics chain supporting drone operations in the southern sector. Fuel supplies, spare parts, and maintenance equipment worth millions of rubles vaporized in seconds, effectively shutting down production for months. The journey home proved just as harrowing as the approach. Russian air defense commanders vectored Su-35S fighters to intercept, but geometry worked against them. The interceptors needed 8 minutes to reach the MiG's position, by which time the Ukrainian pilot would be 75 kilometers closer to friendly airspace. Their advanced missiles had excellent range, but acquiring a target flying at 400 feet through ground clutter exceeded their radar capabilities. Post-mission analysis revealed the true significance of this operation. The GBU-39 weapons had maintained navigation accuracy within 12 meters despite continuous GPS jamming, validating American claims about the weapon's electronic warfare resistance. Ukrainian innovation had transformed a 40-year-old aircraft into a precision strike platform, delivering modern effects through what can only be described as desperate creativity born from necessity. This mission represents more than just military success. It demonstrates how human ingenuity can overcome seemingly impossible odds. Ukrainian technicians took incompatible systems and made them work together through sheer determination. American engineers built weapons robust enough to function in environments they could only theorize about. Together, they created a solution that protected countless civilian lives by shutting down a facility dedicated to terrorizing innocent populations. The broader implications extend far beyond this single mission. Modern warfare increasingly relies on precision rather than overwhelming force, where a handful of accurately placed weapons can achieve what once required massive bombing campaigns. Electronic warfare has become as important as kinetic weapons, creating invisible battles fought in the electromagnetic spectrum that determine the success or failure of conventional operations. This story also highlights the evolving nature of international military cooperation, where allies share not just equipment, but expertise, creating hybrid solutions that neither could achieve alone. The Ukrainian pilot's skill combined with American technology and desperate innovation produced results that military planners are still analyzing today. As military aviation continues evolving, missions like this one provide crucial insights into future warfare. The integration of precision weapons with older aircraft platforms, the importance of electronic warfare resistance, and the value of tactical innovation under pressure all represent lessons that will influence military doctrine for decades to come. The pilot who flew this mission returned safely to friendly airspace, but his story represents something larger than individual courage. It demonstrates how dedication to protecting civilian populations can drive technological innovation and tactical creativity to extraordinary levels. In an era where warfare increasingly targets non-combatants, missions like this one serve as reminders that precision and discrimination in military operations remain not just tactical advantages, but moral imperatives.